Hi everyone, and welcome to another video of Terraform. My name is Tia from DevOps Easy Learning, and today we'll be going through Terraform workflow. What is Terraform workflow? What is basically going on behind the scene when we type Terraform plan or Terraform apply or Terraform destroy, right? Let us kind of jump in here and see what is going on exactly behind the scene when we type Terraform apply. What is the workflow until we kind of see a resource being created in AWS? Let's jump in. If I click on this Terraform logo here, it is going to take me in my GitHub repository here, and I will make sure that I put the link in the description of this video so that if you want to follow the same step, you can go ahead and kind of fork this repository and make sure that you clone the repository locally and you can follow the same steps. Now, here, this is the root of the repository. If you click here, this is basically the root of this repository, but our hands-on exercise, it is at this specific path. And I will make sure that I kind of add this path here, this link here in the description of this video. Now, Terraform workflow, what is going on exactly when we kind of type Terraform plan, Terraform apply, or Terraform destroy? Let us use this little picture here to kind of discuss the workflow. Let me go ahead and kind of grab my Epic pen here that I will be drawing with. Now, let's say you are a Terraform admin and you are here as a Terraform admin. You have your local machine here where you install the Terraform binary, and you kind of pull up your Terraform, the CLI here, right? And when you type Terraform -- version, it is going to display the version of the Terraform that you install. Now, let's say you have some TFR where you kind of put a code maybe to create an EC2 instance in AWS, and you are ready to create that EC2 instance. What are some steps that you are going to perform to create that? You first of all type a command like Terraform validate to kind of check if your configuration syntax are correct. You type Terraform FMT to make sure that you kind of format your code to follow the HashiCorp configuration language. And you will type the Terraform init. We will go ahead and kind of download the provider from the registry, and it's going to store a local. And you can go ahead and type the Terraform plan, and Terraform would generate the plan of what is going to create in AWS. And if you are satisfied with the plan, you can go ahead and type a Terraform apply. And when you type Terraform apply, Terraform will go ahead now and create the actual resource in AWS, right? Now, what is going on behind the scene? The first step here is what? As soon as you have your TFR ready and you want to go ahead and create an EC2 instance, you first of all type this command called Terraform init. What Terraform init is doing is going to the Terraform registry and is going to download the version of the provider that you put on in your code. And when it download that version, it will store it local and it will not perform any further action. Let me repeat myself. The Terraform init is going to the Terraform registry. It is going to download the provider, and we know that the provider is the heart of Terraform. Like in Linux, we will say the kernel also, it is the heart of Linux, right? It will download this provider and it will store it local and it will not do anything. And this provider will basically tell Terraform in which cloud environment you want to create the resource, right? Now, after this, we can move to number 2 when we type a Terraform validate. The Terraform validate command here is going to kind of check all our our TFR to make sure that we don't have any syntax error. And when that passes, we type the Terraform plan. Now, when we type a Terraform plan, what will happen here? Terraform will try to kind of check the current state and the desired state. Because right now, the current state, the desired state, it is what we have here in our configuration file, and the desired state, it is what we have in the TF file, and here the current state, it is what we have live in AWS. As this is the first time that we want to create this EC2 instance, we don't have current state. That means we don't have anything in AWS. What happened here is that when you would have a Terraform plan, Terraform will go ahead, first of all, and check if you have the proper permission to access AWS API. It's going to check if you have the proper permission to access AWS API, which means it will kind of check your .aws file to make sure that you have the access key, the secret access key, and the region where you want when you want Terraform to deploy this resource. And this .aws, it is the same thing like a kubectl, right? If you are working you are working in with Kubernetes, what happens is that if you type kubectl apply, what is going to happen? It is going to check to make sure that you have the proper permission. You have the cluster key, right, to kind of authenticate. If you don't have that cluster key, you will see that you have permission denied. Same thing here. If you have not yet configure your AWS CLI, you have permission denied. Why? Because you will not be able to authenticate through AWS API. And let us assume that you configure your AWS CLI, you have either your access key and your secret access key. Now, it will kind of go, it will go to AWS now and check the user, the IAM user that you want to use, and make sure that the user have the proper permission to create something in AWS. Let's say you are trying to create an instance in AWS. Yeah, it will check the user that you are using, and it's going to check the permission, right, that will basically attach to that user, and see if that user have the right to create an instance in AWS. If the answer is yes, it will go ahead now and generate the plan, and you will see exactly what needs to be done in AWS. And at this point of time, you are ready to kind of tap Terraform apply. And when you tap Terraform apply, Terraform will go ahead now and kind of generate the Terraform.tf state file. And it will go ahead and lock down everything that it created in AWS, so that next time when you tap Terraform apply, it is going to check the desired state and also compare with the state file to see if there's any change. If there is no change, it will tell you that, hey, we don't have anything, right? Everything looks good. But let's say you make some modification again in your local configuration, and you tap Terraform plan, it will go ahead and check what you have in the state file, trying to compare with what you have in AWS. If there is any change, it will tell you that, hey, it looked like we make some modification, and this is what we are going to apply. And let's say you basically make a change in AWS. What happened is that you will see here that your desired state now is not more the same with the current state, which is in AWS. And that is why when you tap Terraform plan, Terraform is going to tell you that it's going to destroy whatever you created in AWS, whatever you modify in AWS manually. Let's say in AWS, you change the instance name, and you're trying to tap Terraform apply. In the state file, the only instance name that Terraform is aware of, it is exactly what we have in the configuration file, which means it will try to revert whatever you put in AWS and kind of trying to make sure that it always matches what we have in the configuration file, right? That's the Terraform goal. Terraform always makes sure that it can match exactly what we have in the configuration file, and make sure that whatever we have in AWS always match that, right? It is the same. It kind of work similar with something called Argo CD. We say Argo CD has two eyes. One is looking at the cluster, another one is looking at the repository, right? The current state, it is what we have also in Kubernetes, and the desired state, it is whatever we have in the repository. And every time, let's say if you modify something in the cluster using kubectl, what happens is that Argo CD will kind of notice that something happened. Somebody make a modification in the cluster, and it will pull whatever we have in the repository and sync in the cluster. But This can happen manually, automatically, IOCD, if you basically enable auto-sync, right? But in Terraform, we don't enable anything. That means it is the next time that you perform an action or Terraform apply that it will make sure that it sync everything properly. Now, let me go ahead here and kind of open a code here, and we'll do some hands-on here to see the behavior. Let me clean this up, and I will navigate into this path here. I'll navigate into this path here and open the code in my and just open this in my VS Code. Let me go ahead here and open my terminal. And I am at the root. I've cloned this repository already, local. Let me go ahead and cd here and put a path. And ls, I am where the code is. I can type code here so that you can confirm. This is exactly what I was trying to explain. And we have this piece of code here. What is it doing? It is really simple. I have the Terraform block here. This is just the required version. This is that we want a Terraform version 1, right? And here, this is the provider that we want to download. And this is the region where we want to kind of deploy this. And here, we basically have the block of code to create an EC2 instance. The first thing here, we just set this IAM. In the region where I'm going to deploy, I basically grab the right AMI version already, and I want to use the T2 micro, and the key that I want to use is already created in my AWS account, which is just Terraform AWS, and I kind of have a VPC security group that is already there. I mean, I went to my default VPC, I kind of create a security group in my default VPC, and I just kind of plug the security group IDs here, as you guys can see. And here, this is the subnet ID. This is just one subnet ID within a default subnet that I have here in AWS. If you guys can see here, this subnet basically ends with C114. If I go to my AWS account and check my default VPC in this region, which is North Virginia, let me type VPC here, VPC, and I'm going to check my default VPC. This is my default VPC, and if you kind of grab the VPC ID here and search all the subnets, it's going to filter all the subnets. And if you guys can see, if you check here, you can see that I have that subnet here, which is 4C14, which is the first one. 4C14, and that is where I grab it. And if you check also, I have two security groups that I created. It is not mandatory that you go ahead also and create two security group, right? And also be aware, if you don't put the subnet ID, what Terraform is going to do is that it will pick up one subnet ID within your default VPC and go ahead and deploy that. And also, I'm just saying here that the root device should just be 10 gig, and this is just a tag, right? I just want the name of that VM to be VM. And now we don't have anything here. Let me go ahead here and kind of open my terminal now and type Terraform plan. This is the first thing. When I type Terraform plan, what is happening here? Terraform will go ahead, not plan, Terraform init first. Terraform will go ahead here and download whatever I put in my code, like the provider. It is downloading, right? It basically download v3.76.1, right? And as you guys can see here, it is based on the condition that I set here. Download anything from 3 to 3.99, but not 4, right? And it kind of chose to go ahead and download the 3.76.1, and it basically downloaded this provider and store it local, as I mentioned, but it did not perform any further action. As you guys can see here, this is the provider here, and when it download it, it can create something here called the provider.h, the provider log.h here, right? To kind of log the provider. And this is only available if you are using Terraform above Terraform 0.14, right? And I will kind of have a video where I will explain exactly, if you want me to kind of like If you guys want me to go through another video to explain how the Terraform log.acl works, please let me know in the comment below, and I'll go ahead and create a specific video just for that. And I will explain to you guys in which version of Terraform we basically started using this log.acl and why we need the log.acl in Terraform, right? That will be a very, very useful one. Please let me know in the comment below if you want a video about that, and I'll go ahead and shoot one. Now, let us go ahead now and check if our configuration file is correct. I'll go ahead here and type the Terraform fmt, the Terraform validate first to see. Validate. Now, everything looks good. If you go ahead now and kind of type the Terraform fmt, this is just to make sure that I will just format my code to follow the HashiCorp configuration language. How you won't see anything here, right? But let me do this. As you guys can know, if you do this and make sure I remove everything, put it like this. In Terraform language, we kind of want to align all these equal, right? But my VS Code is set up the way that if you just go ahead and type Control-S, it will make sure that it formatted. It looks like this is not enabled, but I'll go ahead and enable it and enable it so that when I type Control-S, it will go ahead and format my code based on HashiCorp configuration language. But as you guys can see here, I'm glad that it did not do that. And I will type the Terraform fmt, and you guys will see what it's going to do now, right? Let me go ahead and make sure that we can see this, and I will type Terraform fmt. You guys will see that it will go ahead and format my code. It looks like even formatted. Let me remove something and save it. Cool, it's not formatted. Let me put this now and kind of type Terraform fmt. Just record my command and watch what's going to happen here. Am I in the right directory? Let me click. Oh, it formatted already, right? As you guys can see, it formatted here to kind of follow the HashiCorp configuration language. And that is what the Terraform fmt command is doing. Now, let me go ahead now and type the Terraform plan. Terraform plan. What is going to happen here is that Terraform basically check and see if you kind of have this .aws in my home directory, right? And make sure that I configure my CLI. As you guys can see, I have the credential here to access the AWS API. And that is why Terraform plan works, right? And when it also gets to AWS, it check the IAM user that I have and make sure that I am user basically have the proper permission to create an instance in AWS. And I can go ahead now and kind of type Terraform apply to kind of create the actual resource in AWS. Terraform apply. Terraform apply. And I'll just go ahead and say, yes, I want to do that. And if you just go to my AWS account, you guys will see that very soon, one EC2 instance is going to pop up here, and the name is VM, the same name that we basically put in the tag. Right here, I have one instance running. If you click here, this is one here, which is pending. As you guys can see here, it is in pending state. And very soon, you guys will see that running. Very soon it will be in running state. It is still creating. And this is the Terraform apply command that will go ahead and kind of create the resource in AWS. As you guys can see here, it is done. And if you just go back to my VS Code, you guys will see that I have generated a file here called the Terraform state. Terraform, it generated a state file. If you click here, and it kind of locked down everything, every single thing. This is the name of that VM, right? And this is what we call the desired state. The desired state is what we have here. And the current state, it is what we have in AWS. And let's say tomorrow, somebody just go to AWS and trying to modify this tag here and call this VM Terraform TIA, for instance, and go ahead and save. What will happen here now is that when you type Terraform plan, Terraform will check the configuration, trying to match with what we have in the state file here, and notice that the VM name have changed. And what Terraform is going to do is that it's going to revert that back. Let us check that out. If you go ahead here and kind of tap Terraform plan again, you guys will see that Terraform will notice that something that it is out of sync. You guys will see that it's out of sync. As you guys can see here, the name VM was changed to what? To VM tier. And if you tap Terraform apply, Terraform will go ahead and revert that. Terraform applied. And Terraform will go ahead and revert it back to the name that we're having before. Look, if you hook over to AWS, very soon you guys will see that this name will change to VM, and it changed it already. And let's say you want to change it the proper way, it's basically to change this thing in your configuration file. That means you can go to main, and here you can change this one here. You say VM and maybe EC2. And if you save it here, as you guys can see now, what we have here, our desired state here doesn't basically match the current state. And that is why when we type Terraform plan, Terraform will go ahead and check whatever we have in the state file here, and notice that our configuration file is out of sync. It will kind of try to update the state file and also update what we have in AWS. And if you go ahead here and tap Terraform plan again, Terraform plan, you guys will see that it's going to detect that, hey, we kind of make some changes, and it's going to modify that. So you can see this just means it want to change VM to VM2, and I can go ahead now and tap Terraform apply. Oh, oops, Terraform apply, typo, and it will go ahead and update the resource in AWS. Very soon we'll see here that this name have changed. Let me refresh again one more time. One more time. Why is it taking too long? Let me also check my terminal. Oh, I haven't hit yes. And that is why I was asking myself why it's taking too long, because I just changed the tag and it have to be very fast. Great. Now let us go ahead now and kind of destroy the resource, right? That means we are done. We go ahead now and tap Terraform destroy, and the Terraform destroy command will go ahead and kind of remove all the resources in the state file and remove everything also in AWS. And after this, when we check the state file, you guys will see that there is nothing in our local state file. When the destroy is done, we'll see that there's nothing in our local state file, and also there will be no resource in AWS, and the resource also will disappear, right? And that is why we say Terraform will keep, you basically use the state file to kind of keep it's like the snapshot of everything that we have in AWS, right? That means every single resource that you create in AWS is being locked in that state file, and that is how Terraform basically remember what is in AWS. Now, if you're going to go to my VS Code again one more time and click on that state file, as you guys can see, it's gone, and it will have the state backup here in case you basically destroy this resource by mistake. You can always have the backup of your state file here. That's it for this video, guys, and I will see all of you guys in the next video. Bye-bye.